Hello, in this video I will explain the hierarchy between objects necessary to create different robotic systems. Specifically, I will show the classic hierarchy of an articulated robotic arm and of a wheeled mobile robot. Therefore, the aims of the presentation are, on the one hand, to understand the advantages of using object hierarchy. In addition to this, our goal is to understand the hierarchies typically used for both of an articulated robotic arm and for the case of a wheeled mobile robot. Also, I will mention the recommended method to establish the hierarchy between pure and non-pure objects. The hierarchy between objects is necessary to be able to apply translation or rotation operations on objects in a serial link, as is the case of robots, since the hierarchically superior elements can move the objects that are below. In addition to this, it allows the parent object to access to objects that are hierarchically inferior, to access to their children. And this can be used, for instance, to read data from a sensor. Indeed, the software includes some calculation modules such as the inverse kinematics or motion planning, and these modules, they need, indeed, hierarchical structures. Pure geometries are typically hierarchically superior to non-pure geometries. This is because all collision physics and dynamics are applied to pure geometries, so that non-pure ones will always be associated with the position and orientation of pure geometries. Here we show an example in which we have a pure geometry and a non-pure geometry. The pure geometry is indeed this cube here with the transparency, and the non-pure geometry is indeed this object here inside. As you can see, we have dragged the non-pure object inside the pure object to establish the hierarchy. So obviously, the better adjusted the pure geometry to the non-pure geometry, the more realistic the simulation will be. Now we're going to study the hierarchy between links and joints. In the case of robot arms, we have a serial link structure, so that the first link is the base of the robot and usually is the fixed link, is this one here, and corresponds to this object here. Then after this, we find a set of joints and links in a chain structure. Each joint moves the next link of the chain. For instance, here, this joint here moves this link here, and this joint here moves this link here. And this can be seen here as this hierarchical structure here. In this other example, we will see what we need to use in case of a wheeled mobile robot. In this case, the hierarchically superior element is the robot base, which is this object here and corresponds to this object here. So the base includes two joints corresponding to the left and the wheel joints, and which are this one and this one, which correspond to these two joints. And each of the joints has another link which has the wheel shape here and corresponds to these two objects here. Also, we have a supporting wheel, a caster wheel in this case. We can model this wheel by adding a vertical joint here, which corresponds to this joint here, caster support, which will rotate freely based on the orientation of this joint, and another horizontal joint with a wheel that will be the one which will be indeed contact with the ground. Although we don't show it here, but if our robot will include sensors, for instance, they will be child of the robot base or any other object that will be child of the base. Well, in this video, I have explained the hierarchy between objects in order to build the robot. I will show you how, in more detail, how this articulated robot arm or the wheeled mobile robot work in the CoppeliaSim software in the next videos. Thank you very much.